Okay, we'll get started. So hello everyone. This presentation is called Talking with Your Infrastructure. It's about AI agents and how to sort of work with OpenStack, Kubernetes, or any infrastructure with AI, which is fairly a high-level presentation. On the topic, the agenda today is to give a quick introduction, talk a little bit about LLMs and agents. We'll go on to how to build a sort of an agent or a chatbot using LLMs with RAG, fine-tuning, etc. Do a quick demo on the things that we will talk about, and then if we have time, we'll do some Q&A. Okay, I'll talk about myself. My name is Sulochan Acharya. I work at Rackspace. I've been at Rackspace for quite a long time now. Rackspace now is getting back to, with Infra getting back to doing a lot of OpenStack again. And some of the stuff in this demo, we're using H100 GPUs in Rackspace Spot. So if you're into those kind of stuff, go check it out. Now, AI has been sort of a, we're kind of at an inflection point with AI. Because it's not just about optimizing how to do stuff, optimizing your workflows, or even not just about provisioning AI, but it's more about a fundamental shift in how AI can shift the focus from just doing manual provisioning of workflows into sort of like an automated stuff. And so it's a driving force now, and then we're experimenting a lot of AI-driven operations, and this came about at Rackspace, where I work on a lot of OpenStack related stuff, but I also work on this platform called Pixabay, where it's a platform that sort of brings in OpenStack, Kubernetes, and VMware, all these clouds into one place where you can deploy AI, but also sort of be in a place to experiment with your LLMs and chatbots, right? And so this whole idea of doing AI bots or AI agents for managing infrastructure came about for a purpose of having a unified platform and then allowing those workloads to be deployed through AI. And so basically the vision is, because I'm a big fan of Iron Man, and so when Iron Man talks to Jarvis AI, I always wondered if there was ever a possibility to do something like that. And recently that became more and more clear that there is. So it is going into that direction, right? So voice to text is established technology now, and going into GPTs and having AI now, with LLMs having text into action is becoming more and more clear, like a Jarvis-like AI would at some point be possible. And so the aim was to build something like that. So imagine having an infrastructure like your OpenStack cluster or your Kubernetes cluster, and rather than typing commands or having to know commands, you just question it, saying, hey, can you give me something? Can you build an instance? Can you deploy a workload? Can you provision my Kubernetes workloads? And having that done, right? And that was the vision. That still is the vision, to build an infrastructure like that. And so in building that, you have to be context aware, it has to be data driven, but how do you do that? So, just having an LLM, having a wrapper around LLM, will that work? What is it that we need to have a complete platform that becomes like Jarvis, for example? And that leads us into having AI agents with LLMs as the cognitive layer for this work, and this is where we're going. And so, just to recap, what is an LLM? A large language model is a sophisticated piece of software and its main aim is like a prediction engine. So its main aim is to predict the next word or tokens in a sequence of words, and that's what an LLM is. Its completion capabilities comes from having it trained on a large volume of data, terabytes, petabytes of data. Some of the larger LLMs are very, very huge, right? The amount of data being trained on, and then they have the important thing is they have a context window, which is sort of like their short-term memory, which is how they behave. The context window is recently been growing and growing, which is awesome. And then they might give you an impression of reasoning, but obviously they're not reasoning, they're just predicting next words. So that's very important. So for engineers, OpenStack providers, users, it's important to know that this is not a source of truth. So if we're using an AI agent type stuff to troubleshoot something, you have to understand that whatever an element says might be completely bonkers, right? So that's something that we need to keep in mind. What is it good for? It's an excellent excellent way to recognize patterns, and so you can tell, you can fine tune it, you can teach it to predict how something would go if you ask it a question. But LLM by itself is obviously not enough. I'll actually go to a slide. By itself is not enough. So if you write a wraparound LLM, obviously because it has no context of what you're doing. For example, if you're an OpenStack operator and you're asking a question about, let's say, about something that's broken in your infrastructure, like a build fail, and you ask it a question, it has no idea because it's not trained on that data. It will just give you some generic data that's been trained on. So we need AI agents. And what are agents? Agents are, again, a piece of software. They're sort of like a bunch of autonomous software that take input, interface with your infrastructure, whether it's an API, whether it's documents, whether it's a pre-written something. It will take that, it will reason it with the context, and then it will provide that context back to an LLM to then take another action. So I'm sure we've heard of these AI agent swarms where you put the multiple agents together and then they will troubleshoot your stuff. This is sort of where the way that works is by one LLM taking a command from, let's say, user input, and then providing that command back to, let's say, if you're asking a question about OpenStack, it will pass it on to an OpenStack agent, which will then go query your OpenStack API, come back with an answer, go back to the LLM, and so on. So it works on reasoning, action, and then the feedback then is to go back to the LLM and then feedback back to the user. So LLMs with AI agent is sort of the cognitive layer of where having a Jarvis-like system is going. LLM brings the reasoning, the context understanding, and then the AI agent, sort of the intelligence and action from your infrastructure into it. So agents then bring sort of like a grounding in terms of data to your application. They provide memory and state management. So if you're asking it a question about build failure, it has to go fetch multiple things. It might have to talk to your logs. It might have to query your API, so on and so forth, and then bundle them together to provide that sort of management layer to provide back to the LLM. And so the decision and policy enforcement can happen on this layer. And again, you can talk to your tools and APIs, right? And over time, this sort of cognitive layer sort of evolves into a more reactive, autonomous AI bot. Why do we want LLM agents right now? And there are multiple reasons. LLMs have matured to a state where, just for example, larger models like GPT-4, some of the other are so DeepSeek models are good enough to just answer your questions because they've been trained on such large volumes of data. So even if you ask a question about, okay, what is the right way to fix an issue in OpenStack, I'm sure a lot of us have done that. I do it regularly nowadays. It comes back with the right answer most of the time, right? And so it's good enough that we can use that now as the base of our next level AI agent platform. And then we have lots of telemetry data nowadays, so many APIs, so many monitoring and logging and infrastructure, which all provide data through APIs. And so that's a great way to sort of feed that back into your agent, and then you can make a more sort of decision that's more relevant. And then OpenStack, Kubernetes, they're more hybrid. There's so many, within a cluster, you might have multiple things, you might have multiple clusters, and then just managing that will become difficult. So having a autonomous sort of agent to do that would be right at this point in time. Right? So, and again, move away from manual operations into sort of intent-driven ops. Yeah, again, so Iron Man like Jarvis. Two ways to look at this. So if you're here, you're either an operator, running OpenStack day to day, or you're a user using OpenStack. So you're either spinning up a virtual machine, or you're looking at the backend and saying, this is how it works. And so what we're trying to do is we're trying to build an SRE AI agent or an SRE AI chatbot for backend users, for engineers. If you're a user, you might not know. You could go click on the UI, but you still need to understand how everything works. Let's say you spin up a VM, you have to create a network, you have to create a router, create a floating. You need to understand all that. So for a user who is not very familiar with cloud technologies or OpenStack, we would want to provide a personal cloud AI engineer, which you just say, hey, build me a server, it goes and does that. And so, like I said, agents required, because just having an LLM wrapper is not enough. Simply it doesn't have the context. You ask it to do something, it only knows about the data that it's been trained on, so it's going to come back with something that's maybe not relevant for you most of the time. And so when we were building this, we tried that, and we said, okay, that doesn't work, let's garbage. We'll do something else. The second pass was using LLM with simple function calls, and we'll talk about function calls in a second. So function call is when you say, hey, build me a, or what is the status of my cluster? It goes on, queries your API through a function, and then comes back and says this. It works, but it's still error prone, because your LLM needs to really understand all the functions. And, if you have a large list of functions, it's going to not exactly hallucinate, but it will call a wrong function for a call that it should not be making. And so third, we tried a function call with RAG, so give it a bit of context. So the first call would be, if I ask you a question about instances, look at my vector database, fetch me some context that tells you then to go and look at call a function. That is still, but RAG is sort of like a beast on itself. So if you don't have the right quality of data in, you don't have the right sort of structure in your documents, then again it comes back with wrong answers, right? And so the final pass, which is where we're at right now, is having LLM, which is fine-tuned for your purpose. So in this case, we're fine-tuning it on OpenStack and Kubernetes based stuff. So for example, when I tell it to, what's the status of my instance, it's already been fine-tuned to know that it needs to call a function, and that function is called X, right? So fine-tuning it makes it a bit more focused on your job at hand. So what we did was we fine-tuned GPT-4. We also fine-tuned Quen, which has excellent function calling features. And so these models were able to, once you fine-tune it, were able to correctly then identify, context from your documents with your RAG, and then provide that context back to your agent. So that worked. I mean, there's still a long way to go, but that's sort of like a thing that seems to work so far. And so the strategy then, if you're doing something like this, is model selection is obviously very important. The model that you select, whether it's GPT-4, whatever it is, must do two things. One, it must call functions. It must be very good at calling functions. There are many models which are not very good at calling functions. We were working a lot with, for example, Llama, and it does call functions, but only with like a very large, let's say a Llama, like a 40 billion parameters model, right? Which is kind of hard if you're just running like two GPUs that you run. So in order to make that happen, you need smaller models that you can run within a GPU, two GPUs, and still be very effective at calling models. So your model selection is quite important. Second, fine-tuning model for tool calling. So supervised fine-tuning, which is what we did with GPT-4, with Quen, Llama as well, to some extent. There is a lot of literature around this. I mean, that would be like multiple presentations just to go on fine-tuning. But I'll leave it at that. And then integration of RAG, retrieval augmented generation, which is providing your specific domain knowledge to your AI to your large language model. So select the right sort of vector database. Plenty out there. Have the right document in the right format, and then your RAG then will provide like a proper context to your AI. And finally, the agent AI integration, which combines all of these through agents. So your agent will now do RAG calling, will also query your APIs, and so on. Really high level sort of view is, you have agents, a handover agent, which is how so your LLM, your user input goes into your handover agent. Your handover agent, depending on whatever you're calling. So if you're asking it about your infrastructure in Kubernetes, it will hand over that call over to the Kubernetes agent or OpenStack, or if there is a human in the loop sort of thing, then through chatbot, dashboard, etc. That happens. Obviously, queries, events, and logs. There could be many more here, right? But in our case, this is how we're looking at it. That's the platform we're doing this. It's just a quick view on how that looks like. We'll do a live demo in a second here. Couple of things down here. There's like a front end working, which is the sort of the interface into which you will talk to your cloud. The second thing that's running is an OpenStack agent. You'll see that the main handover agent running there as well. Then the Kubernetes agent, and then the backend that provides sort of everything there. There's other stuff running there, but you just want to focus on those 4 agents plus the backend and front end that's running there. Right? And so the OpenStack AI agent is what we'll focus on. This has the same thing applies for Kubernetes, same thing applies for VMware, whatever you have. But this is sort of like we will focus on the OpenStack part for now. Actually, I'm gonna go straight to this part, which is, so as I said before, when we were writing the agent, it needed to have one function calling. And so this is where we define. I have a whole bunch more down there, but this is how we define for the agent to know what to call when something happens. So these are the available tools for it. So when I ask for, let's say, on OpenStack, when I say, okay, give me what are my OpenStack regions that's within the platform, it needs to know what to call. So when I'm either fine tuning it or when I'm doing a function call, I've defined my functions for the agent itself to know. Second, the function call definition itself. So when the LLM or the agent or the LLM needs to know when it calls the function, what are the sort of the parameters that goes into the function. So if you say creating an instance, it needs to know that I need to call create instance from back there somewhere. So create OpenStack instance, and it needs to know that it needs to call a function, but it also needs to know what parameters to pass into those functions. So right now I said, the very last line, I'm saying just the name and the region is required, everything else I can default. So you could easily just say, like, build me an instance in region X, and then as long as you've configured that region X of OpenStack into your system, it's going to go and build that for you. And then finally, the function itself, this is not very important. Just a basic Python function that eventually will just call a OpenStack API to create your instance, right, or whatever you have. And so the flow then is for your OpenStack API, or sorry, your OpenStack agent. So when you say, what's the status of instance X, the handover agent knows that you're calling OpenStack, it passes that to the OpenStack agent. Given the context, it knows what function to call and what parameters to pass, and then it calls that and then passes that answer back to you, right? So that's basically the flow of things. And here on the back end, so this is how it looks like. When I say, using flavor, blah, image, blah, key pair, etc., create me a new instance in this region. And so the first thing is it get that sort of the context get passed into your handover agent. The handover agent, again, it knows that it needs to call the OpenStack agent, which calls the LLM. So it passes the same thing back to that OpenStack agent. The OpenStack agent then calls LLM, which realizes that you need to do a function call, and so it calls the create OpenStack instance with the provided arguments. The OpenStack agent comes back to OpenStack agent, which does a post call to your OpenStack API. Once that's done, it sends the whole context back to your LLM again. When that's done, you get an answer back. And so that's the flow of how this agent workflow works. Right? And this works for spinning up an instance, works for troubleshooting something, works for doing any automated any sort of work, both on OpenStack and on Kubernetes. That's just an example. We'll do a live one right in a sec. Missing there, I'm probably asking it. That's the build command that I was asking it to. It said build an instance, and it did a build and then came back with that. And so we'll do a live demo in a minute here. And then just so going back to talking with your infrastructure. Once you have this going, I'm choosing just in the demo as well, I'll choose the easier, simpler sort of commands just so that the demo gods are happy with them. There are more complicated ones where you say, go troubleshoot my build failure. That takes time. It'll go in, it'll fetch different things from different places, and then figure out the reason why this build is failing. It takes a few minutes, so we'll skip that. But easier ones, things like like they can do right away. How many regions do I have configured in my system, etc. And those will, again, we'll do in a second. Those will work fairly quickly. And again, this is the sort of like the example of talking with your infrastructure, right? Now we come. So that's great. Those are function calling, agent calling function to do something. We have, as operators, we've all seen cases where we have OpenStack infrastructure, Kubernetes infrastructure laid out, and then we have problems. And so we need to provide, a simple way to figure out how these problems can be solved. And obviously, everyone has their knowledge base; they have their sort of, in-house knowledge base, etc. And you might have, engineers with shift admins, etc., who need to know this, and how do you pass that along? If you have RAG configured in a way that you ingest all your knowledge base into your RAG, this becomes really easy, and we'll see that in a second. Because retrieval augmented generation, what it allows you to retrieve, sort of depending on your query, retrieve the data that you would require to figure out a problem. It will augment that into the context for the large language model to process, and then that would generate the right sort of response for you, right? So let's take a look at this. We'll again do this in a second here. This is one example. How do I deploy? Okay, this one's I'm just asking, how do I deploy Magnum with Cappy? And well, if you don't know how you deploy Magnum with Cappy, you're going to go on the internet, start searching for stuff. If there is a curated documentation, this comes from, again, this is documentation from Rackspace Cloud right now. All that Rackspace Cloud documentation is fed into the system. So when you ask it questions, as long as your vector database has it properly embedded, it's going to come back with a right answer, and that answer is a sort of verified answer from your documentation. Right? So that's one way to do this. Before we go into demo, kind of running on time as well. Sounds awesome, sounds good, but there are integration challenges, especially on security and trust. And so agents are operating sort of your instructions on some region, some production. If you're running this on, how do you make sure that it doesn't disrupt the production stuff? How do you make sure that it's doing the right thing? So there is a lot of and who's doing what? How do you sort of make sure that the right person is doing the right things, etc. So there's trust boundaries. Obviously the data silos. So we need to fetch data logs, but logs have a lot of stuff, right? So does everybody have access to that level of details? Same for metrics and so on. And how do you make sure that there's multi-tenancy within this? So if you're a user, you're asking it a question about your infrastructure. How do you make sure that another user doesn't do the same, or doesn't get the same answer, can do the same? Again, integration with APIs and auth, scalability. How do you make sure that this agentic platform works on multiple regions, multiple clusters, and so on? So there are lots of integration challenges. Like I said, mostly on trust and safety. So because we're working directly with mission critical infrastructure as backend engineers, so we need to make sure that we take care of that. I'm going to rush a little bit because we're running out of time. One thing I do want to mention is, when we're doing agents, we need to make sure that there is some policy guardrails put on, so that agents, it operates within a strict pre-approved boundaries. And so when you're doing this, you say that level A, B, C, D, and this is where whoever asking the question has access to this level of details, etc. And then that guardrails act as a sort of your auth, pre-auth. You have validation pipelines to make sure that you're giving out the right answer. So you might ask it a question. Let's say you have done this and you provide this to your with your clients or your support or whatever you have, and then they ask a question and the LLM gives the wrong answer. Now we need to make sure that validation, that answers are right? Access control, safety, etc. Key takeaways: AI agents, AI in general will help us, build better product for our customers, and will help us troubleshoot stuff as backend engineers, etc. In order to do that, data unification is important. We need to have a very effective way to get that data back. Trust and safety that we just talked about. And finally, the future of SRE is cognitive and collaborative, and let's try to build a Jarvis-like system. We'll do a quick demo. Okay, and so let's go back here. So this is sort of the platform that So if we go back here, we have OpenStack regions, etc. defined right here. So I have my OpenStack here and my Kubernetes cluster here. And so if we go into the chat and say, what are my OpenStack regions? Okay, so we have those two. Let's see if I have any instances here. Okay, I'm going to copy that. And it says, give me details on instance. Thanks. Okay, and that's basically the read. And so we can do something a bit more. So I have a Kubernetes cluster as well. So I can say something like, look at K8's event and tell me the status of my cluster. So I have completely wrong example. No, it didn't. So I have a Kubernetes cluster configured here, and then it's saying, looking at the events, I have some DNS config formation errors, etc. So it tells you, what's unhealthy, etc. So that's another one. So let's build an instance just to be. I have the command handy here, so I'm just going to copy this. So using flavor, this is again the same from the example. Using flavor, can you build me an instance? And if we go back to OpenStack, I have my instance here, just call that.
Refresh that.
there you go. There's a build happening. That was what this came back with. And so again, I'm picking easy examples where you can do the same with why did my build of instance X failed, or what happened to network this, etc. And it will go. That will take a long time, but it will fetch. It will go and fetch information from your logs and from your APIs, etc., and then come back with an answer. We're really running on time, so that's basically what we're trying to build. And as we build this, make it more and more sophisticated, be able to do sort of more autonomous action. So there is pipelines where if an error happens, actually the last one that I want to show with RAG is, so we have infrastructure with a bunch of stuff happening. I'm just picking this as an example. And so a MariaDB replication is broken. I click on this. I have a very specific instruction for it to do similarity search from my database for my issue. And hopefully it came back with the right. Yeah, it did. So it says this is how you fix MariaDB replication. This is right from your knowledge base, and so it becomes really easy. And so you can do this basically for every single problem that we might have in your infrastructure. So in this case, it's MariaDB broken. Could be anything else. And so I'm sure we all have our own sort of knowledge base to work on, and then this can help. We're on time, so thank you very much. Happy to take questions or